two-level atom, if we have a two-level atom and this has a state Ca of T A plus Cb of T B, and then psi will be equal to Ca of T star A plus Cb of T star and B. And if we find the density matrix operator psi and psi, then we must have a multiplication this state and this state, Ca of T A plus Cb of T B and Ca of T star A plus Cb of T star B. Then it means that we must multiply this with this. If we multiply this with this, we have Ca of T absolute square AA. If we multiply this with this, then we have Ca of T, Cb of T star, A, B. Then this with this plus Cb of T, Ca of T star, Ba. And this with this, we have Cb of T absolute square, B. I want to find out the probability of a particle in state A. Then what I can do? I must take A, rho, and A. I must multiply this side with A and this side with A and the whole equation. Then it must give me rho AA. And then similar situation can occur here. If I multiply this with A and from this side with A, then it must have Ca of T absolute square, A, and A. It means that I multiply with inner product A with this side and A with this side. So this A remains the same, these are both remain the same, and this A and this A. And similar situation can occur here. And let's see, this is equal to 1 and this is equal to 1. And similarly, if I multiply from this side A and from this side A, so this is B, this will be equal to 0. And similarly, A from this side, so AB, this will be equal to 0. And A from this side, this will be also equal to 0. So it means that we have only this term, and this is equal to 1 and 1. So it means that Ca of T absolute square. And we know about this Ca of T absolute square, the probability amplitude. And probability amplitude method, this is known as the probability of finding a particle in state A. So it means that rho AA, which is equal to Ca of T absolute square. So both are the same. And this density matrix equation, if we have a rho AA, it means that this is the probability amplitude, the probability of finding a particle in state A. And similarly, if we find out the probability rho BB, then we must multiply this side with B and this side with B. Then it means that if we multiply this side with B, this will be cancelled out, this will be cancelled out, this will be cancelled out, and this will be equal to 1. And we must get Cb of T absolute square. So it means that rho BB will be equal to Cb of T absolute square. And similarly, we can find the row AB as well. This is the coherence, this is the dipole between the two levels, the strength of the dipole. And we can also find out. For example, if we find row AB, it means that we must multiply this with A and this right side with B to this equation. If we multiply this with A and this with B, this will be equal to 0. This with A and this with B, this will not be equal to 0, but this will be equal to 1 and this will be equal to 1, and we have CA of t and CB star of t, and the remaining will be equal to 0. And similarly, the reverse as the row B A, then CA star and CB. So this is the method that you can take the two-level atom and you can find out row AA and row BB. In matrix form, row can be written as CA of t absolute square and CB of t absolute square, and here CACB star, CA of t and CB star of t, and here CA of t star and CB of t. This is the matrix in matrix form, and this is actually equal to row AA, row AB, row BA, and row BB. So this is important. Row will be equal to this. And how we can write this row in this matrix form? For this, we can use the Spanner notation. We can use the Spanner notation. And Spanner notation, psi can be written as CA of t and CB of t, where this in Spanner notation we can write this CA of t star and CB of t star. So this is a matrix and this is a matrix, and if I write the density matrix psi, then we must have CA of t in a matrix form and CB of t in a matrix form, and this is also in a matrix form, CA of t star and CB of t star. Then multiply row into column, then it means that CA of t absolute square, and this row into column, CA of t and CB star of t, and here row into column, this is CB of t, CA of t star, and row into column, CB of t and CB of t star, and it means that CB of t absolute square. So this is remains to this. It means that this can be obtained by using the Spanner notation.